Yes, we are continuing with our organic chemistry, and we are saying we are in this very topic we call polymerization. And we look at polymerization in detail and we say it is simply the process by which polymers are formed by, from monomers. And now, there we reach at a deeper chemistry and we say because of that, these monomers are of different types. So that means if monomers are like that, we came up with something called addition polymerization and what? Condensation polymerization. And we said in addition polymerization is just a type of polymerization whereby the unsaturated monomers combine to form what we call a single product. And that single product is what we call the polymer itself. So now, because of that, we look critically at addition polymerization and we came up with some products, how we can produce a natural rubber, even the synthetic rubber. Now, today we are going to look at what we call condensation polymerization. You have ever heard of condensation from your primary up to now? But here now, when we say condensation polymerization, is that type of polymerization where these molecules which are bifunctional. Now we need to be very careful now here when we say bifunctional. So those those monomers which have different, let's say two, they are meaning two what? Two functional group. That's what they are meaning. So these molecules which are bifunctional react together to form what we call polymer with the loss of simple molecules like water can be lost in the process. Of course, ammonia can be lost in the process. We have also others. So we shall therefore say ETC. Because we shall see later, even the hydrogen chloride can be released in the process. So when you look at this definition carefully, when someone tells you differentiate between condensation and polymerization and additional polymerization, this must appear in your definition. You say it's for condensation polymerization is a type of polymerization whereby the molecules, which are the monomers, which are bifunctional, react together to form what we call a polymer. And now the polymer formed here, they are also being formed with other minor molecules like water, ammonia, etc. Now, if you have known the correct definition of this, we shall now come to the examples and see what do we mean actually by these bifunctional molecules. We shall see critically. Now, previously we said a functional group is that site, the reacting site of that very molecule. That's why when we look at alcohol, we say the functional group in alcohol is the hydroxyl ions. And we also said this was for alcohol, of course. And we say the functional group for, okay, when we look at alkene, we say the functional group is this double bond between these carbon atoms. We also say that in alkyne, the functional group is something of this kind. Then we proceeded and said for what we call the carboxylic acids, and if we don't want to call them like that, we say it that we shall call them alkanoic acids. We looked at their functional group also and said the functional group is written like that. So this is the functional group for carboxylic acids. But then we also said if we don't have functional group, then there are also other constituents which are attached to the chain. And those constituents we said we can mean to have the chloro group. We can also mean to have the nitro group and then etc. So we shall be in position to see those one there. So when we say the molecule is bifunctional, we are in fact meaning this thing. So there should be this molecule that you are combined together. This one might have this functional group, another one will be any of these functional group, and you'll be in position to get your polymer formed by condensation process. Now, after us knowing this functional group very well, we shall now say it. These examples, we shall be in position to distinguish which functional group are we dealing with. Is it the one of alkene? Is it the one of alkynes? Is it the one of alcohols? Or the one of what? Carboxylic acids. And we shall continue. And we say if you don't know something about functional group in organic chemistry, that means you don't know organic chemistry, because you'll not be in position to distinguish. You cannot distinguish between the different what? Different organic compounds. So here we say, example here is nylon 66. So this nylon 66, we shall see how it is formed. And we're saying it's just a polyamine. So when you say polyamine, so that means the amines are there already. So here, I will say it, amine. These constituents, we have what we call the amines, then etc. So for the amines, you will be in position to at least see something like this. For the chloro group, is just Cl. For the nitro, is something like this. Sometimes, yes, accompanied by this. Then here for amine, we shall have something like this. Now, we need to understand that when we are dealing with organic chemistry, still we are focusing behind, where we say each of these atoms here, they have a specific of maximum bonds that they can accommodate. And we say for carbons, is having 4 bonds. For it can accommodate 4 bonds. And we say it, so here I will say it, for carbons, you will see it like this. That means it is stable. If it is lacking, that means it is not stable. Then for nitrogen, for oxygen, we say it 2 bonds. Then also for nitrogen, we say it 3. And then we say it also for hydrogen is just like that. So the moment you know this part in organic chemistry, and you also come and know something to do with functional group, you're good to go. Because this is what you're going to deal with here. Now, let's say this is a polyamide made by polymerization from 6 carbon dicarboxylic acid. So when you say 6 carbon, that means there are 6 carbon atoms. We shall say 1, 2, 3, 4, 5, 6. 6 carbon atoms. 6 carbon dicarboxylic acids. And now, at the end of the day, you will see that there is that functional group for what? Carboxylic acids. And 6 carbon diamine. So that means also you say 1, 2, 3, 4, 5, 6. But there is that constituent attached to it, which is called the what? The amine. So this part here, you will be in position to see it from here. Now, this is what we are describing as a 6 carbon dicarboxylic acid. This one. So when I open this thing up, we shall be in position to see. But since we have gone forward organic chemistry, if you have been following, you'll know that this 4 stand for this whatever in the bracket here. So we shall say we shall have 4 carbons plus this, we shall have 6 carbons here. Then when we say it, this one also, this 4 also belong to what is inside. So here we shall have 8 hydrogen. But now the most important thing here is for us to know the name of this one and how to write it chemical. So here, 6 carbon atoms. So here we say the name is xn because we shall count 1, 2, 3, 4, 5, 6. Xn 1. Now here they are showing the positions. So let me show it clearly here so that you will not have any problem when you are trying to follow these notes critically. Okay, so here we shall be in position to say, let's come up with this. We have something of this kind. And we say these there are 6 carbon atoms here. But let's just attach it like this, and we say CH2. Of course, this bracket, and we put 2. Then we shall have something like this. Then we have the OH here. So if you are critical enough, then this part alone, this is the functional group for what we call the carboxylic acids or the alkanoic acids. This part also is the same as this. Now, the reason why we are saying hexane 1,6, this become the carbon 1, this become the carbon 6. So we shall now start from here. We are seeing the functional group is here, the functional group is here. So we shall be easily say hexane 1,6 di, 2 of them dioic acid. Let's come to the one of amine. So here also we have 6 carbon atoms. So if there are 6, so we shall say 1, 2, 3, 4, 5, 6. Then now, of course, you will attach the hydrogen atoms. But then this one here is on this. The one for nitrogen, this is hydrogen, hydrogen attached. Then also the same thing here, like this, we have a hydrogen, hydrogen attached. So here there are hydrogen atoms, of course, here. So this is carbon 1, this is carbon 6. So again, we shall say it. For us to name this one, it is called hexane 1,6 di. 2 of them come together, we say diamine. Or if you don't want to call it like that, you can start from here and say 1. You put your comma and say 6 diamine. The 2 of them, 1, 2 diamine. Then the long chains 1, 2, 3, 4, 5, 6 is where the hexane is coming from. Now, when we hit this thing together, we shall be in position to form what we call nylon 6,6. Okay, now here this N stands for the number of what? The number of what? Monomers. So these are the monomers. I can say this is monomer. This one also is the monomer. But now, N indicates that several of them, of course, can combine together to form what we call nylon 6,6. But the condition here is heat. So this chemistry here is very simple. What happened here is that here you're not seeing another hydrogen. So this another hydrogen can simply combine with the OH from here. That's why you're seeing here the OH is not longer there. You combine with this OH. So that means this one of the hydrogen atoms from here will combine with this OH. And if you have OH and this will form for us water molecules. So after that combination, also there is this part which is coming, one of the hydrogen atom from here will come and what? Combine with this OH and also form another what? Water molecules. And then from there, we shall now get what we call 2 molecules of water. Now, after the formation of these 2 molecules of water, there is this bond going to be created between these monomers, which are bifunctional. They have different functional unit, functional group. So here we say we are left with one H here. So we have this one hydrogen here. We have one hydrogen here. So that means then there is this bond going to be created between this carbon and this nitrogen. That's why you are seeing this like this. Then we shall be in position to form nylon 6,6. Now, this N is telling us that others can still come in, combine, like from here to very, very, very far place. Okay, let's come here. How about if we come for this one also? We said here we have hexane 1,6 dicarbonyl dichloride. If you don't want to call it like that, you can also call it hexane dichloride. Now, here is just these chloro groups here. That's why we say hexane 1,6 dicarbonyl. This one here, we're going to talk about carbonyl compounds ahead. This is their functional group already. We shall talk about this functional group ahead of us. And then that's why we are saying di. Two of them, dicarbonyl dichloride. This one here. Okay, after knowing that, we shall also combine it with the same, this other monomer, which is what we call the XN16 diamine. Then what is happening here when you heat this thing together is the same reaction. We shall get what we call nylon 6 again. This is the product called nylon 6. If you have ever heard of nylon, so there's hyphen missing here. So you have nylon 6 like that. So when you look at this one critically, also what happened is that this chloro group combine with one hydrogen from here, then they form hydrogen chloride. This one here is not the acid, hydrogen chloride gas. Then now another, this one will also come and combine with another hydrogen from here, then they form what we call another hydrogen chloride. So these two of them combine and we put them here, and the product form here is what we call nylon 60, and it is a polymer. And the polymer formed by what we call addition, condensation, polymerization.